Hey there, everybody. Mr. Simon here. It is Sunday. What is today? I think May 3rd. So we are heading into week 6 of our online lessons. I know that you're probably not enjoying it near as much as school. I would echo that the teachers feel the same way. But hopefully, you're all hanging in there, learning a little bit, getting some time off. A beautiful day today. Wow. I went for a 7-mile walk with a buddy of mine just to catch up. That was awesome. Feels good just to wear shorts and be barefoot in the house too. So hopefully that weather keeps up. Just checking in, and I got a couple cool demonstrations to show you. I'm going to make a test tube disappear right before your very eyes, and hopefully it comes through on this recording. And this actually has to do with last week's discussion on the refraction of light, the bending of light as it goes from one medium to another. So first demonstration is one showing fiber optics. For those of you that were on Zoom last week, you're able to, we talked about this. By the way, join us on Zoom, 10 to 11 o'clock for honors physics on Tuesdays and Thursdays. We've been getting somewhere between usually 15 and 25 people on. The more the merrier. And sometimes we have little announcements. We work through some of the homework problems together. We've even gone through some of the quiz and test problems together. Because the main thing is we want you to learn some things. So first thing is on fiber optics, glass cables. So you go back 20 or 30 years, we carried communication via electricity with copper wires, and that works very fine. Copper is very cheap metal, not a problem. But in the last 10, 15 years, a lot of our communication lines have been replaced with fiber optics, which are actual glass cables. Here's an actual fiber optics cable that has hundreds and hundreds of glass cables in them, and the glass cables are so small, they're fractions of the diameter of the human hair. You can actually bend them without breaking. And glass can carry light signals from point A to point B, just like electricity can carry electrical signals from point A to point B. Fiber optics using glass cables is a lot cheap, not a lot cheaper. It's a little bit more expensive, but a lot clearer of communication because you lose less energy because it's total internal reflection, meaning all the light gets internally reflected through that glass cable without escaping, as opposed to electricity where you lose some of the energy due to the heat. So the first demonstration has an enlarged, it's a plexiglass cable. I'm going to take my nice powerful green laser. I'm going to turn my light off so it comes in a little bit better. But you can see if I shine it through there, maybe you can't see, put it down here a little bit, that the green light actually gets all the way through that glass cable. In fact, at the end, there's a nice green dot. So without light, with light. And technically what's happening in this cable is not total internal reflection, because if it was total internal reflection, you would not see any of the green light in the tube. All you'd see is green light at the end. So it's a demonstration piece of equipment just to show you that light is carried inside. It might not come through on my computer, but if you look here, you can actually see light bouncing off a few times as it partially reflects through the cable. So not sure how well you can see that, but obviously in my living room, I can see that pretty well. So pretty cool. It's really revolutionized a couple different places in our society. Obviously the communication system, and the other way is through medicine. So now doctors, instead of cutting the body open with big scars, can make little holes and send fiber optic cables in there and illuminate little parts of the body, and they can actually see what's going on without having to cut open the body with large scars. Another demonstration, this one's pretty cool. So I'm going to probably lose my head as I show you a disappearing test tube. I'm going to use my magic formula, otherwise known as vegetable oil, which happens to have the same index of refraction of Pyrex glass, like the test tube you used in chemistry class. So normally I can see something like glass because glass has a different index of refraction than air does. So the light that's hitting the glass, some of it's refracting through and it bends as it goes through the glass. It bends as it goes from air to glass, then glass to air, then air to glass, and glass to air. I also have some light reflecting off of it. So most things have what we call partial reflection, partial refraction. Some of the light reflects off, some of the light refracts through, which is why when you look down into water or you look through a window, you can often see a little bit of a reflection of yourself, an image of yourself, not only see through that glass. So normally I can see things that we call transparent because they're not totally transparent. They're making the light refract. Nothing's truly transparent except for vacant space or maybe a pocket of air that has a consistent density and temperature. So as light's going from me to the computer, it's going through this chunk of air, which has an index of refraction of 1. Technically 1.0003, but close enough that we call it 1. Pyrex glass is an index refraction, somewhere around 1.4. So light's going to bend as it goes through and bounce as it comes off. And that allows us to see the things we call transparent. Well, my vegetable oil just happens to have the same index of refraction as Pyrex glass does. So if you look through the glass and I put my test tube in, you can see the test tube there. But technically what you're seeing is the pocket of air that's in the test tube. Because the oil and the Pyrex has the same index of refraction, it's like light going from one piece of air to the next piece of air. It doesn't refract if there's no change in the index of refraction. But watch what happens when I take my magic potion, otherwise known as this nice Crisco pure vegetable oil, and I pour it into that test tube. Keep your eyes on that tube. And if you do so, you're going to see that test tube disappear. Pretty cool. Moving it back and forth, and you can't see it at all because, again, light is not refracting when it hits the Pyrex glass. The oil and the Pyrex has almost the exact same index of refraction. So again, air, now filled with oil, test tube disappears. In fact, it works so well that the whole time you're doing this, and this is pretty cool if I do this in class, the whole time you're looking at this, there's actually a test tube in here. I got to get it out. The whole time that you never even saw. So if I put that test tube in and let it fill with oil, it disappears. Pretty cool. Not only that, but the whole time you're watching this, I had another beaker inside of that beaker that you probably never saw. Wow. What was that? Wow. I had to be careful to line up the writing with the back glass. So before I did this demonstration, sunk the whole beaker inside the outside beaker. Pretty cool. Now I got vegetable oil all over my computer, so we'll have to worry about that later. Again, I hope you guys are doing well. We're trying to limit our workload to be less than 3 hours every week. We had a little glitch with the con videos. So we've found out, thanks to Bruno, that if you right click on the con video, it will open it up to a new link and Buzz will record that video. You just clicked on it regular, Buzz was not recording that video. The Crash Course videos are recorded. So I have no con videos this week, but if I do it in the future, I'll put it on through the YouTube link, not the con video link. As long as it's through the YouTube link, it will record the time that you're looking at. So I hope you guys are doing well. I hope that experiment was as fun for you as it was for me, because I enjoy doing this every year. The disappearing test tube. Pretty cool. All right, people, have a wonderful week. Go out and get some exercise on those nice days. Enjoy some family time. Put some puzzles together. Play some games. And join me on Zoom. We're having a great time. All right, folks, we will talk to you hopefully sooner rather than later. Have a great day.